workshop. Vou fazer aqui uma breve leitura. Acho que está passando o som para cá, né? Só os problemas técnicos acontecem em qualquer lugar, né?
Ele ligou.
Acho que sempre estava sem som aqui. Bom dia a todos. Então, é com grande satisfação, né, em nome da Universidade de Caxias do Sul e da área de Ciências Exatas e Engenharia, que damos abertura, então, ao primeiro workshop de moldes para rotomoldagem. Então, é com grande satisfação que recebemos todos vocês aqui, né, que foi cuidadosamente planejado esse evento, né, para momentos, na verdade, de troca, de experiências, discussões, né, no setor de rotomoldagem. Então, o primeiro workshop de moldes para rotomoldagem está sendo promovido pelo projeto Melhorias no Projeto Fabricação, Montagem de Moldes de Tanques Rotomoldados, que é realizado em conjunto, então, entre as universidades de Caxias do Sul, o Cefet Minas e a PUC Minas, que tem o financiamento, então, do programa Mover do Fundeb. Conta com a participação das seguintes empresas, né? A Grale, a GCO, a Mazzocchini, a Xalingo, a Modelação Felser, Dirk Design, Voa Indústria, Empresas Icon e AB Infer. E este evento, então, está sendo apoiado pela empresa Rota Sul-Americana. Bom, eu vou falar um pouquinho sobre... Teríamos a minha programação ali, mas não está passando. Isso, não sei. É que acho que tu projetou agora, João. Tem que voltar. Tudo bem. Bom, eu vou comentar um pouquinho sobre como vai acontecer nosso dia de hoje, né? Então, a gente, pela manhã, infelizmente, a gente teve um imprevisto com relação a Caxias do Sul, que todo mundo, né, conhece o nosso clima. 2 palestrantes iriam pousar em Caxias ontem e, infelizmente, né, devido ao clima, não conseguiram pousar. Um deles é o nosso coordenador geral do projeto, que é o Yokio Shigaki. Então, ele vai fazer a sua breve apresentação e explicação do nosso projeto no início via, então, projeção, certo? Além disso, então, a gente vai ter um hall de 4 palestras, né? E depois, às 10 horas, uma pausa para um coffee break. Depois, a gente tem, então, também, durante a manhã, 2 palestras que também vão ser transmitidas aqui no laboratório, ia dizer, né? A pessoa voltada ao laboratório, né? Aqui no auditório. São 2 representantes, então, de empresas italianas. Ao meio-dia, a gente convida, então, para um almoço, né? Que a gente sugere ir no restaurante Rossini, onde faz, então, esse almoço por adesão, do meio-dia a 1. Então, na verdade, nossa agenda de hoje vai ser bastante apertada. A gente pretende, então, no início da tarde, fazer uma visita guiada aos laboratórios. Então, quem não conhece a universidade, que vai ter a oportunidade de conhecer 2 dos nossos laboratórios, né, que a gente presta serviço também com relação a isso, no início da tarde. Então, da 1 às 2 da tarde. A ideia é a gente se encontrar na frente do restaurante, em torno de 12h50, para descermos ali, então, no laboratório, né, em conjunto, todo mundo em grupo, para visitar esse laboratório. Tá? Esses 2 laboratórios, na verdade. Eu peço, então, a gente deixou na entrada uma listinha da visita guiada. Quem não preencheu, depois eu vou passar de novo essa listinha, para a gente ter uma ideia de quantas pessoas vão, para a gente organizar, então, com os técnicos dos laboratórios. Tá? Então, estão todos, obviamente, convidados. De tarde, então, a gente tem um hall de mais 3 palestras. Um dos participantes também não conseguiu vir, que é um representante de uma empresa de São Paulo. Também vai ser transmitido, então, via YouTube, né? A gente liberou o link para vocês também. O evento tem uma previsão de encerrar às 15h45 e, após isso, a gente vai fazer uma reunião, então, com a equipe interna do projeto. Bom, Obviamente, a gente encoraja todo mundo a ser bastante ativo durante o workshop. Esse é um momento, né, não de só passar informação, mas de ter a maior troca possível de informação, né, do setor. Bom, sem mais delongas, pessoal, então a gente declara, né, oficialmente aberto o primeiro workshop para moldes para rotomoldagem. Esperamos que todos aproveitem ao máximo e muito obrigada e aproveitem o evento.
Registrar a presença do nosso diretor de área, né?
Sim,
Eu vou lá para outra sala.
eu tinha dito que eu não. Então, só para ficar, né, a nível protocolar, estamos dentro de uma universidade. Hoje temos a representação, então, do nosso diretor da área do conhecimento de Ciências Exatas e Engenharia, professor André Adami, né? Eu ia dizer o Adami, né, porque comumente chamado, certo? Gente, muito obrigada. Então, inicialmente, a gente vai ter a palavra do nosso coordenador geral do projeto, o Yokio Shigaki, que teve a impossibilidade de chegar ontem. Então, agora tu pode transmitir, João, aqui.
Bom dia, vocês me ouvem bem aí? Bom dia.
Bom dia, Yokio. Bom dia.
Bom dia, vocês me ouvem bem aí?
Sim.
Ok. Bom dia a todos, a todas aí. Muito obrigado pela presença. Como a professora Jardina já comentou, tanto eu quanto o professor Janes Landry, da PUC, e o professor Sandro Cardoso, do Cefet, nós estávamos no aeroporto de Confins, indo para Caxias do Sul, e aí esse que o nosso voo foi cancelado de última hora, e nós tentamos aí de várias maneiras, né, tentar chegar aí via Canoas, tentar chegar aí via Florianópolis, e não foi possível. Então, infelizmente, não pudemos estar aí, né, fisicamente, uma coisa que a gente teria, enfim, seria muito bom que a gente tivesse aí, né, ver a todos aí. Alguns professores aqui da nossa equipe não conhecem, os outros professores também. Mas, enfim, são coisas da vida, né? Alguns de vocês já sabem que nós tentamos realizar o primeiro workshop em maio e também não foi possível, né, devido ao desastre, né, que houve aí, né, no Rio Grande do Sul. Mas, enfim, tirando isso, vamos tocando o projeto. Vocês conseguem ver a apresentação aí do PowerPoint que eu preparei? Tá, parece que sim. Bom, eu tenho pouco tempo para falar, já gastei alguns minutos aí, né? Mas, enfim, esse projeto, pessoal, é promovido pelo Mover, né, do governo federal, né, a Fundep é a organizadora geral. É um projeto que a Universidade de Caxias do Sul, o Cefet, né, o Centro Federal de Educação Tecnológica em Minas Gerais, e a PUC Minas, né, a Universidade Católica de Minas Gerais, nós estamos desenvolvendo esse projeto junto também com a Fundação Cefet Minas. Okay? Como a professora Jardina já disse, né, são melhorias no projeto, fabricação e montagem de moldes tanques rotomoldados, e isso foi uma demanda das empresas automotivas brasileiras, né, e também ligadas ao setor agrícola, para a gente investigar, né, sobre o projeto, fabricação e montagem desses moldes, de um processo assim que, pelo que a gente tem visto, não há muita publicação, não há muita pesquisa assim aparente, né? E aí é um projeto em que a gente une a academia, as empresas e as fundações para a gente tentar desenvolver, tentar estudar um pouco mais a fundo, desenvolver alguns moldes demonstradores, né? E entender os reais custos que aparecem, né? Que acontecem aí nesse processo todo, e tentar melhorar a qualidade a nível internacional, né? Fazendo todo esse mapeamento, né, das empresas relacionadas aqui no nosso país, certo? Fazendo visitas técnicas a empresas, tanto nacionais quanto internacionais, conversando também com os pesquisadores daqui do país e também de fora, e participando também de alguns eventos internacionais, né? Antes de eu prosseguir, eu gostaria de agradecer à Universidade de Caxias do Sul por estar recebendo, né, o nosso workshop, nosso primeiro workshop aí, talvez o primeiro workshop de moldes para rotomoldagens que já ocorreu, né, aqui no Brasil. Agradecer também à comissão organizadora, né, a professora Jade na Catafesta, que encabeçou aí todo esse processo de organização do evento. Né, nós agradecemos bastante também, não conheço o professor Adame, mas também agradeço aí o apoio dado aí ao nosso projeto. Prosseguindo aqui, esse projeto faz parte da linha 4, chamada Ferramentarias Brasileiras Mais Competitivas, tá certo? Né, do projeto Mover, antigo Rota 2030, talvez vocês conheçam mais esse nome, esse segundo nome, né, que é Rota 2030, que agora mudou para Mobilidade Verde. Okay? Então, a nossa ideia é unir a academia, empresas e fundações para tentar resolver ou tentar melhorar, né, a fabricação de moldes, o seu projeto, né, tudo relacionado à rotomoldagem. É um projeto que se iniciou em julho de 2023, período de vigência de 20 meses, né, um valor aí, contando o financiamento do projeto e também as contrapartidas das empresas e das ICTs, né, no valor total de 2,2 milhões de reais. O Instituto de Ciência e Tecnologia, né, a coordenadora geral, a Cefet, né, onde eu trabalho, e também o coordenador associado, né, da UCS e o coordenador associado da PUC Minas Gerais também. Né, está coordenando esse projeto aí. E as empresas envolvidas, a professora já comentou, mas eu faço questão de nomeá-las, né, a GCO, o ACO, a Agrale, Xalingo, Mazzucchini, a VOA, né, a ICOM, né, a Indústrias Convento, isso, a Associação Brasileira da Indústria de Ferramentais, né, a BINFER, a Dirk Henning e também a modelação Felser. Como objetivo, a gente quer consolidar, harmonizar e difundir os atuais conhecimentos, competências e boas práticas, né, da rotomoldagem e da fabricação em especial, né, a fabricação aí dos moldes de rotomoldagem. A gente tem constatado que não há muito conhecimento difundido, né, o que a gente tem visto assim nos artigos aí publicados aí internacionais, nacionais e internacionais, se refere mais aos materiais, mas não tanto ao processo em si e em relação à fabricação dos moldes, né? E a nossa intenção é, fazendo essa pesquisa mais aprofundada e conversando com especialistas nacionais e internacionais, a gente tentar melhorar a tecnologia da produção desses moldes. Né? Como eu já disse para vocês, isso aqui nós pretendemos atender, né, a uma demanda do mercado, né, com relação aos moldes de rotomoldagem, né? E fazer esses estudos técnicos que já estamos fazendo, né? O professor Carlos, mais tarde, vai apresentar os resultados parciais do nosso projeto, que já tem bastante coisa feita, né? E como dizia um dos organizadores aí desse projeto, né, do Rota 2030, né, do Mover, a nossa intenção é a gente diminuir prazos, melhorar a qualidade, né, e melhorar o tempo de entrega desses moldes. Né? E para isso a gente vai estar fabricando 3 moldes, né, para a gente identificar os reais custos, né, as dificuldades, né, as dores, digamos assim, né, do projeto e da fabricação desses moldes, e também nós vamos testá-lo, né, em chão de fábrica. E todo esse conhecimento ele vai ser difundido, né, vai ser divulgado, porque esse é o grande objetivo do Mover, tá certo? E também a formação também de recursos humanos nesse setor. Então, só adiantando um pouquinho, né, o professor Carlos vai me xingar aqui, mas a gente vai primeiro fabricar um vaso de pressão pequeno para a gente entender o processo, por três processos de fabricação diferentes, tá? Depois um tanque que a Agrale forneceu de 44 litros, vai passar aí um tanque metálico para um tanque aí de polietileno, né? E depois, finalmente, um tanque maior, né, fornecido pela ACO. E como processos, a gente identificou primeiro a usinagem a partir de um bloco de alumínio, né? Isso já está sendo feito, né, com relação ao molde aí para rotomoldagem do vaso de pressão. A fundição e acabamento, que a gente tem visto também, né, talvez menos utilizado, mas aparece, né? E também, por último, a fabricar o molde usando chapas, né, fazendo o seu corte. Aqui tem uma novidade, que é a conformação incremental, né, que o professor Janes, mais tarde, fará uma apresentação só sobre esse processo. É um processo muito interessante, em que ele consegue aplicar detalhes na chapa, né, que de outro modo não seria possível fazer, e a parte de soldagem e acabamento. Tá? Então, a equipe de professores aqui, eu sou coordenador geral, né, eu sou professor aqui, titular aqui do Cefet. Nós temos os coordenadores associados, o professor Carlos Alberto Costa, da UCS, que também é professor titular, e o professor Janes Landry, né, da PUC de Minas Gerais, e os outros professores, a professora Jade Nakatafesta, né, da UCS, o professor Alexandre Facini Michels, também da UCS, e o professor Sandro Cardoso Santos, do Cefet. Vários alunos, né, estudantes participam do nosso projeto, né, da UCS, a Paula, o Roberto e o Gerson, né, o Roberto inclusive vai fazer uma apresentação mais tarde, né. Da PUC nós temos aí o Marco Danilo, o Marcos Nobre, o Henrique, e do Cefet o Gabriel Ferreira e o Gabriel Borges de Guimarães. Então esses são os recursos humanos, né, que a gente está formando através desse processo, desse projeto. E as equipes parceiras, eu fico muito feliz em ter essa equipe com a gente, né? As empresas aí que são parceiras desde o começo, né? Que assinaram aí o acordo de parceria, né? E estão contribuindo tanto técnica, né? Quanto com contrapartidas econômicas, né? Então, da Xalingo, o senhor Rodrigo Herbert Hastein, o Edson Cavalheiro, o Carlos Balparda, da Agrário, o Joel Michelon, né? E o Gabriel Balbinot, né? Dick Henning, né, que está ajudando bastante a gente na parte de projeto dos moldes, né, a passagem, né, do metal para o plástico, digamos assim. A ICOM, né, Indústrias Convento, o senhor Eli Fortunato, o senhor Jairo, né, e a Jamile, né, nós agradecemos muito o apoio de vocês também. Né, e a ACO, o Leonardo Silva, o Ricardo Graça, Guilherme Schenkel e o Matheus Santos também, que nos tem ajudado bastante, fornecendo também o desenho aí de um tanque maior, né? A Feusa, né, o Vitor Hugo, que vai estar nos ajudando também na parte de fundição. A Voa, né, o senhor Arthur Ornelas, né, a empresa daqui de Minas, né, que vai estar nos ajudando também na parte de usinagem, também com formação de chapas. A Mazuquinha também, né, a Mazuquinha é daí de Caxias do Sul, né, o senhor Patrick. Por fim, o senhor Christian Dilma, né, a Binfer, né, que tem nos ajudado bastante com o apoio. Então, nossos agradecimentos, né, a todos vocês pelo apoio, né, que nos tem dado, e é uma equipe que é bastante completa, ou seja, cada parte cumpre uma determinada etapa que é fundamental no nosso projeto e tem ajudado bastante mesmo a desenvolvê-los, né? Por último, também a Fundação Cefet Minas, né, que aqui gerencia aí os recursos, né, do projeto. O professor Flávio Antônio Santos, que é o diretor, né, da Fundação. A senhora Ana Carolina Brasil, a senhora Ângela Vargas e a senhora Mirtes também, né, eu não posso deixar de citá-las, porque tem ajudado bastante a gente na parte de compra de materiais, compra de passagens e pagamento das bolsas, né, e assim por diante. E também, assim, ao longo do nosso projeto, até o momento, recebemos alguns apoios também, né? A Rotopol, que é a associação lá europeia, né, de rotomoldagem, a ARN também, né, que é a associação de rotomoldagem aí, internacional, e o professor Carlos apresentou um trabalho ali na Rotopol, né, lá se não me engano, foi na República Tcheca ou na Polônia, né, depois na Polônia também. E a gente também vai participar do Rotoplas 2024, que é um congresso aí internacional que ocorrerá nos Estados Unidos agora, em setembro, né, onde estarão participando mais de 400 empresas aí relacionadas ao setor de rotomoldagem. Bom, meu tempo está acabando, Então, tá aí a programação, né? Vocês já sabem, já conhecem. Eu queria aproveitar para agradecer também o Bruno Rota da Pérsico, que tanto ele quanto o senhor Luca Sacchi, né? Da Polivinil na Itália, né? Ambos na Itália, nos receberam muito bem, né? Na nossa visita lá no começo do ano. Também agradecer ao senhor Alessandro, né? Da Alfamec, que vai ministrar uma das palestras aí. Né? O Roberto, que é da nossa equipe, também vai ministrar outra palestra. Né? O senhor Ismar Moraes também, agradecendo aqui a Rota Sul-Americana, né? Máquinas, para comentar aqui sobre os processos de rotomoldagem, as máquinas, moldes, né? Matérias-primas. E, por fim, o professor Carlos Alberto, nosso coordenador associado aí da UCS, que vai fazer uma apresentação parcial aí, né? Apresentação, perdão, dos resultados parciais do nosso projeto. Então, agradeço novamente. Infelizmente, não pudemos estar aí. Nossa vontade de estar aí era muito grande, mas, né, por condições aí climáticas, não pudemos estar. Mas agradeço a presença de todos vocês. Espero que aproveitem bem o evento. É um evento para a gente trocar várias informações, né? E nós contamos com a ajuda de vocês para a gente desenvolver esse projeto e conseguir atingir os objetivos aí a contento, né? Agradeço novamente a professora Jadna pela organização do evento e a equipe da UCS toda, né? E desejo a vocês todos um ótimo evento, um ótimo dia, que seja bastante produtivo. Muito obrigado.
Ok, obrigada, Yokio, então, pela tua apresentação. E, sendo assim, a gente vai dar continuidade, né, ao workshop, com a apresentação, então, do palestrante externo, né, internacional, onde a gente vai ter a projeção dele aqui. Então, desde já, eu peço que todo mundo que tiver questionamentos, ao final da palestra dele, a gente vai, então, através do microfone, a gente consegue falar com eles. O professor Carlos está em outra sala, fazendo essa intermediação com ele. Então, todo mundo anota suas questões aí e a gente faz pelo microfone. Podemos fazer em português, a palestra dele vai ser em inglês, mas podemos fazer em português e o professor traduz para ele depois. Certo? Encorajo todo mundo a fazer perguntas. Beleza? Então, gente, vamos dar continuidade.
Good morning, Bruno. Can you hear me?
Yeah, good morning, Carlos. Good morning, everybody.
Hello. Thank you. Thank you very much for your time and for this morning, afternoon there. I'm just making a brief introduction, okay? And then just after you may start your presentation.
Yeah.
Thank you once again. We'd like to welcome to our primeiro workshop in moldes para rotomoldagem, first rotomolding tool workshop. And I'd like to open this section by welcoming our distinguished speaker of this morning, Mr. Bruno Rota, who is addressing the topic Intelligent Tools for Rotomolding, ou Ferramentas Inteligentes para Rotomoldagem. Thank you very much, Bruno, for your time, and it's really nice to see you again. Bruno Rota is a key account manager of Persico Company in Italy since 2022. Bruno has a degree in energy engineering, and he took his master's degree in energy, oil, and gas engineering. Bruno is also a volleyball player and is now involved with a new hobby, 3D printing, which is most of people really enjoy. I would like to also to say that we are transmitting this presentation on YouTube platform and also to the conference room straight here at the University of Caxias do Sul. Everyone is invited to make questions and that will be answered just after the presentation. So without any further delay, let's move to Bruno's presentation. Bruno, once again, thank you very much for your time. You have the word.
Yeah, thank you, Carlos, for your nice introduction and to give me the possibility to be here and give a presentation. Yes, so now we can just start with with our presentation. Okay, so just to understand, this is the first time I use this system.
Me too. I have never used this.
Okay.
But I don't know if the menu is in Portuguese for you, but is there one screen, apresentar?
Yeah, okay.
Yeah. And then it's supposed to ask for which screen you want to show, I think.
Okay. You should see my screen now.
Okay, good, perfect.
Okay.
Perfect.
Okay. Good. So before I start more deeply in rotomolding, I would like to spend a couple of words to talk about Persico, who we are, and what Persico does in all its business. So we are not only dedicated to rotomolding technologies. We can provide to customer a full range of services and solution, starting from what we will see later. So rotomolding, tool and machine for rotomolding, but we have also an automotive department that is mainly focused on interiors. So automotive, we work with OEM and tier one, and we have a wide range of technology like compression molds, back injection, automatic line, and so on. We have also a marine department that is focused on the production of boat, catamaran, yacht for both private and competition. The most famous is Luna Rossa, that is racing now in the America's Cup, but we will work, as I said, also for private. In the last year, we worked also in the aerospace business. So we started a few years ago with a project in the aerospace fields, and recently we bought also the German company Bielomatic that is specialized in welding of plastic parts, especially for medical purposes. So like plastic beds for bloods and so on. We have sites all over the world. The headquarters and main sites in Italy, in Embro, where I worked. But we have sites in North America, Mexico, China, and other parts. Mainly are for automotive and marine. But last year we bought a tool maker in the USA because it's a very great market for us, and we want to increase our presence in the USA. We want to have people there, but of course now we are training, and we want that this site will reach our standard in quality, in type of work, and so on. So now we have also this rotomolding site in the USA. So now let's focus more on the rotomolding world, what we do in Persico. Rotomolding is a really nice technology that can provide a lot of solution for a wide range of application. Talking about the final parts that you can obtain with rotomolding, you can really space on very large fields of application, starting from tractor and trucks and the earth moving machine, where we can do tanks, roof, interior, all with rotomolding, mud guards, and so on. So a lot of parts for this type of vehicle can be achieved with rotomolding technology. When we work a lot also with designer and architect to provide the best solution to a lot of final parts. Here are some example that you can see. but this type of market is very huge, and every day there are some new design parts that can be studied together. So designers come to Persico, and we can study together the solution from the very beginning to the end of the project to obtain this kind of product. And then again, with rotomolding, you can achieve also very hard technical parts, like floor cleaning machine, very complex to obtain, a lot of parts, a lot of cores. So not easy to obtain with other technology, but also with rotomolding, you need a lot of knowledge in order to obtain this kind of parts. But also hydrogen tanks that it seems to be easy, but of course you have to be very careful and very precise to obtain this kind of product, because we have to resist a very high pressure, and so everything should be perfect, need to be perfect in order to produce this kind of product. And again, also with these two type of product, we can assist the customer from the very beginning to the development, and then till the final part is obtained. Here just a quick introduction on how rotomolding works. I think that most of you already know it, but just to briefly explain, you have a tool that is made on 2 or more parts. You put plastic powder inside, and then you put it in an oven and start to rotate. The plastic part is weld, melts, and cover all the surface of the tool. So when it's completely distributed on the internal surfaces of the tool, you can extract it from the oven, start the cooling, again rotating the tool on the 2 axes, and then when it's cold, you can open the tool and demold the part. In this way, you can achieve a complete hollow plastic part without any welding, without any stress inside, and so it's a nice technology to obtain this kind of product. Here, a brief overview of what we as Persico do for rotomolding market. So as I said, we start from the very beginning. So if customer comes to us with an idea, we start with the design and co-design of a part to make it suitable for rotomolding. And then when we achieve a part that is okay for rotomolding and okay for the customer purposes, we start with the design of the tool. Of course, we share our idea with the customer to be sure that everything is okay, and we produce the tool. That could be steel tool, cast aluminum, or aluminum CNC tool. We can also make prototyping for customer. We have a pole of competence. We have an oven. We have a smart machine, so we can also try the tool in house before delivering it to the customer. And we make also electric machine for rotomolding that can be combined also with automation. Later we will see better in the detail. And of course, we don't work only with rotomolders, but also with designer, final customers, and plastic suppliers for research and development. Here some example of tools that we can provide, starting from steel tool that are suitable for a very big product, not a lot of detail. Because it's cheap, is not the best quality in CNC, but for a certain type of product is the right technology. Increasing the quality of a final part and of the tool, we can work and provide cast tools. So aluminium with a casting process. We create the shell of aluminium, and then of course we work to make it suitable for work in rotomolding. And the most precise and higher quality tool, that is the CNC tool. So starting from billets of aluminium, we CNC the shape that we want to obtain, and then we work with finishing, frame, and so on. On the surface of the tool, we can obtain very different type of effect, starting from the most common, so industrial smooth, shock pin, SCNC, but for a certain type of product that could be design product or both, and so on, we can obtain different type of effect. Here some example, like the wood effect, the mirror finished. We can work the surface with laser to obtain the texture that the customer wants, and we can again collaborate together with the customer to study, and at the end obtain the result that the customer have in mind. Rotomolding is divided in two parts. The traditional one that work with a standard oven, so a closed room with gas that burnt, and the temperature inside the oven increase, and of course there is a heat exchange with the tool, and this is the standard rotomolding. That is the first three type of machine. And as Persico, in this type of rotomolding, we provide only the molds, and then there is the automatic rotomolding, where we can provide Leonardo machine and smart machine, and in this case there is no the standard oven as the traditional one, but there is the Leonardo machine that work with hot oil, and the smart machine that work with electricity, and we can now see better in the detail. We started at the beginning of the century with the first Leonardo machine, and was completely oil heated, because we want to introduce something new in the rotomolding world, something that can give to the customer more solution, benefits in terms of time, in terms of material. So we started studying the Leonardo machine with hot oil, and then we develop our technology through the year. Initially, again with Leonardo machine, but heated electrically, and then we started also with smart machine. Again, completely electrically heated. With this kind of machine, of course, because you don't have the oven and the hot temperature, it's easier to introduce automation, partial automation or full automation of a process. So together with smart machine, we can introduce robot and all the automatic systems that can make the 100% of a work automated. Here's a picture of a Leonardo machine. So as I said, it's completely different from the traditional one, because there is no the oven, and all the heated is due to the hot oil that flow inside some pipes that are on the tool. Also the cooling is faster, because you can use, instead of only air or water, you can use cold oil again in this pipe, so it is in direct contact with the tool, and you can speed up the cooling, and of course with controlling the flow of the oil, you can control better the process and the heating and the cooling of all the of the area of a tool. And again, in this case, you can implement automation on the machine, on the tool. In the photo, you see also the filling of the powder on the top. So when the cycle is completed, the machine can open on itself, extract the part, fill the powder, close, and restart another cycle. So here you can see a video that show is done in collaboration with our customer and show their approach to rotomolding. We work a lot of here with them, and they start from the very beginning with traditional rotomolding, and then together with us we study some solution for them with Leonardo machine, and then with smart machine. So let's see this video that explain better of the technology.
My name is Gunther Laube. I am production engineer here at Kercher in Winnenden and responsible for the plastic production for the professional plants in Germany. We started the rotomolding in 2004, and we bought a traditional machine with 4 independent arms and used cast molds for the first rotomolding parts. Persico was and is one of the leading mold makers in Italy. So we find good prices, a good support, and also a good quality, which was comparable with our customer here in Germany. We found the rotomolded parts out of the CNC milled mold were more precise in the shape and followed more the 3D shape of the part. Also, the flanges were fitting better together, so we had less afterworking and a better quality of the products. We had a project with a tank of higher mounts, and so we found the Leonardo technology very interesting because of the automation of the whole process. So we found production costs were lower because we need no person to operate the mold and demolding the parts. We saved up to 25% of energy and of course also of material because we were able to adjust the wall thickness better. Not all of our parts are possible to produce with the Leonardo technology. If they have inserts, we had to stop the automatic cycle, which is not good. Also, the dimension is sometimes a problem. With the smart machine, we can do these things. In our opinion, the smart machine is the most energy efficient way to produce the parts. It is easy to adjust the wall thickness by choosing the power of the electric heaters, even in critical areas. So we get enough wall thickness there. It is more easy to create parts with deep holes or long tubes, where you have always a problem with the traditional machines. With the smart machine, you have only to adjust the heating power and you have enough wall thickness. We are at the startup phase now, and we're only able to produce some parts. Up to now, we have reduced 10% of weight at the part, which is good. And we found that the shape of the part is very good, very precise, because of the internal air we use at the cooling process. Our molds have been never easy because we use very complex parts, so the mold needs to have many inserts and loose parts. So it was always important to discuss the project and find a good solution, which was working at the end to have success. With the Leonardo technology, we were able to produce our tanks with the highest amounts with less production costs. With the smart technology, it's easier to rotate parts out of other materials than polyethylene. I think every time we put out of the rotomolding technology all that we can, we have new possibilities for the future.
Okay, so as the video explained, our solution with Leonardo and Smart Machine is done in order to give some advantages to a customer, possibility to make more complex geometry, possibility to save time, energy, material, and the possibility to use different type of material. In the video was already introduced our smart technology, and so this is a tool of that work on the smart machine, and in order to provide the heat to a tool. Again, we don't have an oven, but as you can see on the external surface of the tool here, you can see a lot of electric heaters that are controlled by the machine in order to give the right amount of energy and heating to the tool. Thanks to this technology, our customer can have a lot of advantages. Saving some energy, because all the energy that are provided to the electric heaters are then converted in heat and transfer to the internal side of the tool. So there is no heat leakage has happened in an oven. There is no the operation that is common in traditional rotomolding. When you open the oven and you waste a lot of heat, we have maybe a small tool in a big oven. So here all the energy is concentrated on the tool. You can reduce the amount of material because you can manage the heating in different area of the molds. More critical, you can increase the thickness in that area and not in all the part. You can reduce the material in scrap area, and so you can optimize the total weight of a powder that you use for any cycle. Because you can always use the same set of parameter, you will always obtain the same type of product. And so also the process is there is a process repeatability to obtain always the same product, and controlling the heating and the cooling with also all the probes that are inside of the tool and connected to the machine. You can achieve a shorter cycle. Of course, again, having electric heaters all around the mold, you can create a uniform thickness and manage the thickness in different areas. So no problem of long cores, parts that are difficult to heat, as in standard rotomolding. And you can also manage the deformation and warpage, again, controlling the temperature and the pressure inside the tool. Thanks to all the control that you can put on the process with Smart Machine, you can use more type of material easily with respect to rotomolding technology, standard rotomolding, so with a oven. So here we can see how is a standard machine. This is our 2.8 machine, so it's down to the diameter of a machine, but of course we can adapt the dimension of the machine depending on the product. Here in this type of machine, we can control up to 48 different zones. So if you have a lot of critical part where you can increase the heat, with this kind of machine you can. So on a tool you have a lot of different zones divided basing on the heat that you want to give the product in all the areas, and you can control all of them with the power that you provide to the electrical heaters, and you can measure in lifetime the temperature in each area. As you can see, it's also an advantage in terms of dimension, because it's quite smaller if you think on a standard rotomolding oven. So it's very small. Then here is a quick overview from the top of the machine with the operator. And with this kind of machine, of course, what we want to give to the customer is the possibility to make innovation in the design of the parts in order to have more complex geometry. And of course, another very good point of this kind of machine is the safety. We provide all the safety tools together with the machine in order that the operator can work 100% in a safety environment. Here is a scheme of how it works. You can see all the different color on the tool are different zone of the tool where you can, as I said before, vary the heat transfer. So on the flanges, on the top part, on the two side parts, you can decide how much powder and how is the temperature that you want to achieve. Of course, you cannot only control the temperature, but there are also a lot of systems that can improve the quality of the part. You can generate vacuum inside of the tool. There are gaskets on the flanges of the tool. You can put nitrogen inside of the tool to extract oxygen and avoid oxidation of the part. You can pressurize the internal part of the tool, again, to control better the deformation and warpage. And of course, you can pump air inside of the tool for have also internal cooling. As I said at the beginning, this type of technology is suitable also for introduce automation, because here you don't have to manage with hot temperature outside of the tool. So we develop a lot of system to help the customer to automatize the process. So we can propose a semi-automation like the one that is shown in this picture, that can involve the opening and the closing of the tool, the pneumatic clamps. You can move the loose part. You can put out the parts of the tool with pneumatic ejectors. We can, of course, have a automatic powder dosing and everything. But here is still a semi-automation, because, of course, the work of one operator is still needed to take the parts out of the tool and so on. But of course, what we can provide is also 100% automation. So in combination with robot, we can study together with the customer a fully automatic line. So in these cases, there is a robot, smart machine with all of the automatic system, a system for the weight of the powder, and again the robot that fills the powder inside the tool. And of course, when the cycle is finished, the robot can take the part from the mold and put out of the line. So in this case, 100% of the work related to the process is automatic. And we can see in this quick video some example of lines that we made. So thanks to all these advantages that the smart machine, smart technology, and the automation can give to the customer, what we want to do is to give more solution to the customer, and we think that the future is today, and so we want to help our customer to be now in the future with all these kind of advantages. We of course think that the collaboration with all these automatic lines, robot, and the human way of thinking, human work can be and is the solution for rotational molding war for different type of aspects. Not only for a better process, but also in terms of sustainability, energy efficiency, and safety. So this is our technology, our proposal, and I want to thank you for the attention and to have given me this opportunity to show you this presentation.
Hi, thank you very much, Bruno. It's a really nice presentation. We have the chance to visit Persico in it's Nembro, no? It's Bergamo.
Yes, Nembro.
And it is amazing what they do there in terms of tools and machines and innovation. And it's really nice to hear about this.
Thank you.
I'm just making a little translation to Portuguese, ok?
Ok.
Some parts. Eu estou dizendo só que a gente teve a chance de visitar a planta deles na Itália, e o que eles fazem lá é fantástico. Realmente, o nível de qualidade das ferramentas, assim, de acabamento que eles conseguem é algo assim que eu não tinha visto, assim, né? O nível de polimento que eles conseguem nas ferramentas, tá? But just one thing that I would start a question. No, it's not a question. It's we know that Europe is quite strong in these issues like energy saving, recycling, ecology, and things like this. And it seems that this kind of solutions goes meeting these requirements. Okay, yeah. No discussion about this, and it's quite innovative. It's different. But when we see, and we have a lot of people from industry in our workshop here today, but when we see from the, let's say, payback point of view, Bruno, this kind of technology usually is more, in a first moment, is more direct to production, quantity, production, repeatability, or complex parts. Can you make any statement about this? Pessoal, eu perguntei para ele basicamente que ok, é uma tecnologia que prevê economia, a Europa está muito forte nisso, e obviamente eles pagam um preço por essa economia. Mas a minha pergunta para ele é o quê? Do ponto de vista de payback, né? De pagar o retorno do investimento. Isso aí seria, assim, num primeiro momento, mais focado para uma produção mais seriada de peças repetitivas ou para peças mais complexas devido à característica do processo? Thank you, Bruno.
Okay, so if it depends on which part of a process you're looking for. Of course, if we talk about automation, a robot, a big system, this in terms of payback is good if you have high productivity. So if you have a high number in order to justify the initial investment. But of course, if we talk about smart machine alone with electric tools, so that you can control, but manual, so without any automatic system, a robot, and a lot of big system. Yes, it's suitable also for smaller production in terms of savings, energy savings, material savings. But as you said, in terms especially for very complex part. Because maybe some very high technical and complex part with standard rotomolding, you can have a lot of scrap. Here, of course, you can reduce a lot, and once you have find the right parameter, you can continue to use the same parameter and obtain the same product. So you can achieve a number close to zero scrap. So also in this kind of way of thinking is optimization of a process.
Okay, great. In fact, I saw one of those machines in one company in Poland. It's quite nice working, and the people from the company were quite happy with the results they were achieving. So it was interesting to see, because eventually you see a new technology, but not in industry. In this case, I think that you have provided a lot of units already, I suppose.
Yeah, it's right. As you said, it's always difficult to change the way of thinking of on someone that maybe worked for 20, 30 years with the same type of technology. But then when they try, our customers are happy with the solution, happy with the process, and so we are happy as well, because we satisfy our customer needs, and in our opinion, this is the way of proceed for rotomolding. Yeah.
Okay, and I have just another question, Bruno, because you mentioned in the beginning of your presentation the co-design. Usually you have to find a solution with your customers, and these pass by different, eventually the customer changing or opening some restrictions, some requirements in order to achieve the good tool to produce the part. Our project, our research project, has one of these points about designing the tools, and I'd like to know if you can talk a little. I don't know. I know that you are not the designer guy inside of the CAD computer, no? But what kind of constraints or requirements usually are more the trade-offs, the difficult one to deal in rotomolding parts? Pessoal, eu perguntei, sorry, Bruno, eu perguntei para ele basicamente quais são as restrições normalmente que tem que ser negociada quando se parte para o projeto de uma peça rotomoldada, né? Porque ele mencionou lá no começo a questão do co-design, né? Que é o projeto feito com o cliente, com o fornecedor. Então, eu perguntei para ele quais são os principais pontos que vamos dizer assim, que são mais suscetíveis à discussão no momento que eu estou projetando a ferramenta. Thank you, Bruno.
So of course there are a lot of aspects that we have to consider to optimize the design for rotomolding. As I said, our co-design not always start from a DD file. Some customer comes to us with an idea, but no design. So in this case, we start from the very beginning. And in this case, we already know how to make the 3D suitable for rotomolding. Sometimes, as you said, customers come to us with a 3D that is not suitable for this kind of technology. And so there are a lot of aspects to consider. So the demolding of the parts. So the parts should be easy to demold. So the right draft angle, undercuts that could be done, but you have also to already think on the manufacturing of the tool. So what is also on the external parts, so the flanges, how to put the flanges, the frame, all the clamps or loose parts that have to be moved, and you have to think that there is an operator that have to work easily without any safety issues. And so it's not only design in terms of the process itself and the opening, but you have to think also how people have to work on the tool.
Okay. I think that we lost. Are you there, Bruno? Sound?
Sorry?
Okay. Perfect. I thought that I have lost your sound.
Okay.
Bruno, I have one question here from Ismael. He's asking about if this kind of technology is allowed is involving more advanced materials. I suppose that he's asking about the processing material, the polymer. I think
Okay.
so.
Yeah. We have a R&D department that is dealing, testing always new material that is maybe difficult to use on standard rotomolding. One example that I can do is polycarbonate, very hard to obtain with standard rotomolding that could be easily used with a smart machine. But because of the control of the temperature and of all the system of vacuum, nitrogen, pressurization that you can use to avoid the oxidation, you can avoid bubble inside the plastic part. In this way, you can open the rotomolding to always new type of material. And we are still looking for a new material, always trying, as I said at the beginning of the presentation, we collaborate with material supplier to find a new material, but it's something that we already found together again with customer the solution to some material that with standard rotomolding is not possible.
Okay, thank you, Bruno. Bruno, I have another question here. It's from Fabrizio, and he asked about the thickness uniformity or control. So he asked basically what's the difference between the Leonardo machines approach and process like blow molding, for example. I suppose that one of the answer is the size, but there is any another points that you should stress about?
Yeah, of course. Leonardo machine have all the benefit of rotomolding, so no stress inside the plastic parts, and the real advantages in wall thickness is that you can control it. So if you want it uniform, it can be uniform. If you want one area that is thicker and one area that is thin, you can do it because you can control the quantity of heat on all the areas. And controlling the quantity of heat, you can control the thickness of the plastic in each different area. So of course, if you need a lot of area with a lot of different thickness, you can. If you have some critical area that for a reason of strength, you need to increase the thickness, you can, and you don't have to increase the thickness on all the other parts. So you can save a lot of material.
Okay, and talking about this, you mentioned that when you design a tool, we saw those wires, heating wires. Usually, if I want to make some changes, you do in terms of increasing or decreasing the power of this heating, or when you design a tool, you say, well, this part is not needed, so I'm not putting in any wire, any heating system, because if you have all the tool all covered by the heating system, you can control any precise thing. If you don't have, of course, you have a cheaper tool, but otherwise you have some advantages. Usually, how you decide this?
Usually, we put electric wires all on the tool, and then we can decide which part can be heated, which not. Also, because In this way, yes, we can work at the beginning together with the customer to optimize the process. But then, of course, the customer may need some changes in the way of heat here, and he can do it only work on the panels. With panels that there is on the machine, changing the parameters, and you already have all the heaters that you can change and so on. You can make experiment, test, and so on. So all the tool is covered with electric heaters.
Great. Let's move to the conference room. I don't know if the guys can. Yeah, Bruno, you can see Jadina is the lady that we have talked in the emails. Jadina Catafesta, our professor at university. Hi, Jadina.
Hi, Bruno.
Hi.
We have some people.
Pode. Quer falar aqui no microfone já?
Have you made your course in Portuguese, Bruno?
Em português, okay.
Unfortunately, not yet.
Não parla nada português. Ok.
Qual seria a tendência de desenvolvimentos próximos, né, da tecnologia de rotomoldagem para eficiência energética? E se eles têm alguma experiência sobre aquecimento por indução, que é uma tendência hoje, nós temos uma boa experiência aqui no Brasil, inclusive de aplicação para injeção e para extrusão.
I don't know if you get some words, but the question is related with what's the tendency in this energy saving and approaches for rotomolding, and also if you have tested or if you have an experience about induction heating, because the person told that in Brazil you have some experience with injection molding in this induction heating. I don't know if you have any experience or doing anything related.
Not yet related to this kind of technology that we can propose. Of course, our research and development is always looking for new type of solution, and is doing testing on all this type of technology. So in our research and development, yes, it's something that we already look at, but at the moment, no, we don't have any solution for this kind of technology.
Okay, and moving to I don't know, Jadina, I have one question here from YouTube, but the person asked Bruno about the clamps for this kind of machines, if they have any special design for the heating in this case, or no?
The ones that we use on smart machine don't need any particular heat resistance because they are outside of the tool, and so they don't see the heat of the tool. The temperature around the clamps are, yes, a little bit higher than their environment, but it cannot create any problems to the clamps. And this is one of the advantages because, with standard rotomoldings, also in this case, we have some pneumatic clamps that have to resist high temperatures. But of course, can be a problem. With a smart machine and the Leonardo machine, no, because the temperature outside of the tool never reach high level.
Okay. Thank you. Well, Jadina, maybe we have time for a last question, if anyone in the audience has.
Let's try English. Bruno, good morning.
Good morning.
This process is very high quality. Even it's a high quality process, are there any losses in this process, if there is a percentage of it?
But of course, all the process can be optimized. You can also always introduce energy efficiency in every process. Of course, the electric heaters are in contact also with air, so a small percentage of the heat are wasted in the environment. But of course, the overall efficiency that we have to compare is the standard rotomolding. So in this, looking at this way is more efficient, but of course always can be improved. And of course we don't stop to develop our technology. We are working on it every day in order to introduce optimization again.
Okay, it's okay, Guilherme.
Maybe do you have any numbers, maybe a percentage of loss in this process to share?
I should check with my technology, but what I can say is that the heat transfer through the aluminum is much higher than the heat that is lost on the air. So the energy efficiency, if it's not 100%, it is still very high.
Mm-hmm. Okay. Well, Bruno, we are achieving the time that you promised us, and I ask you.
Yeah.
So I really thank you for your time. Thanks to Persico and your director for sharing with us this part. I know that you have much more, but this part of technology that Persico is working. It's really nice to see you again. I hope the next time we can. I'm not going to play volleyball with you because I'm quite out of it. But I hope to see you again.
Thank you, Carlos, and thank you everybody to give me the opportunity of being here today and explain part of what we can do. And it was a pleasure to be part of this presentation. Thank you very much.
Okay, thank you very much. Bye-bye, Bruno. See
Bye.
you. Bye. Ok, Jadina, é contigo.
Ok. Agora vamos dar continuidade aqui, então. Tu desliga ali agora. Bom, então a gente vai dar continuidade, né? A gente tem a palestra agora do Roberto. Vamos só instalar aqui uns minutinhos, a gente já